Problem 26. We're still in chapter 29. So what do we have here? We have a proton, right? Positively charged object, of which flies through the magnetic field. The value of the magnetic field is given 0.5 Tesla. It's a large magnetic field, right? You remember some of the strongest magnets can produce magnetic fields of a few Tesla. 0.5 Tesla, it's a reasonably large magnetic field, right? So, and it is in the positive x direction. So you see B, I drew it, it is in the positive x direction. Then velocity of the proton is known. It's okay, 10 to the power of 7 meters per second. It's a quite a speed, right? And so let's, for example, I don't know, imagine at this particular moment of time, okay, this moment of time, some arbitrary moment of time actually, right? The proton is over here. And I position my coordinate system, the origin. I position the origin of my coordinate system at the point where the proton is at this moment of time. And x-axis that way, z-axis up. And I tried to draw three-dimensional picture. So this y-axis is basically into the board. I just didn't want to draw over here a circle with the cross because also it will be on top of this proton. So just too much of information at the same point. So I did my best to draw a three-dimensional picture. So the y-axis is into the board basically, right? Okay, and we also know that this velocity, of course, I can actually adjust my coordinate system, and I can make it true. So velocity lies in the xz plane, right? You remember, you have constitutional freedom to choose or to use any coordinate system you want, right? You can adjust it, you can align your axis in any way you want, right? So it's up to you. So let's say I aligned my coordinate system in such a way so that velocity v is in xz plane. And that's how problem is stated, right? Okay, so what do we need to find? We need to find the force acting on this proton. Actually, I forgot to write what we need to find. So let me add that. So find F. Okay, I should have added vector sign. So usually, of course, we should discuss physics, right, first. But here, not much to discuss because we are in this problem basically at the fundamental level, right? So we have a charged point charge, right, which exposed to the magnetic field. Of course, we know this fact. Of course, they're going to interact. And how do we describe that? Using fundamental formula. So pretty much, since we are, as I said, at the fundamental level, so not much to discuss. So we just need to grab that formula, Lorentz force, magnetic force, and just apply it carefully, right? So in this case, it's just a, I don't know, point and shoot, right? So let me write down first, of course, the magnetic force, Q V cross B, right? So that's the beginning. And now force, it's a vector. So we need to look separately at direction and magnitude, right? Two parts. So let me first start with magnitude. Magnitude, right? Wait, no. I said let's start with direction. No, I want to start with the direction. You know what? It's not a big a deal, right? You can start with the magnitude. But I first want to get rid of direction, question about a direction, and then magnitude. Okay, direction, you remember 1.5 steps. First, you need to apply right-hand rule number 1 to find the direction of the cross product. And then, since we have a positively charged object, proton, so it's actually just one step. You just need to look at the direction of the cross product. Okay, so let's apply it. V cross B. First, align your hand along the first vector. I'm not going to align like usually. I will align like this. Otherwise, I will show a weird sign, right? So V, right? And then I need to orient my hand in such a way so that I can bend my fingers in the direction of B. B points that way, so like this. So my hand must be positioned like this, right? Only in this position I can bend my fingers in the direction of B. Right? And my outstretched thumb gives me direction of the cross product, which is into the board. right? Because again, if I position my hand like this, for example, no way I can bend my fingers in the direction of B, right? So it must be like this. And so direction is into the screen. Okay, let me check if I apply it. Yeah. And into the screen, I mean into the board, is our y direction, positive y direction. Okay. So V cross B, of course, it's a right hand rule. Okay, number one. So it gives us into the board. So which is plus a y direction, plus y direction. Right. And so now magnitude. Right. Okay, so now you see I didn't draw vector sign on top. It means it's a absolute value of the force. Did I use just the sign? Yeah. So let me use it like this. Write it like this: Q V cross B, right? And I put an absolute value sign because now we know the direction. Now we just need to know the magnitude. Okay, so charge is positive, and I will probably just use, yeah, Q, charge is positive. Then speed, B, and sine of the angle between these two vectors, V and B. Which angle do we have to use? This is the correct angle. The problem says that the angle between velocity and the magnetic field is 45 degrees. It's given in the problem. I forgot to mention when I was discussing the problem, but that angle is given. Right, and that is the correct angle because tails of both vectors are at the same point. So that is the correct angle. So I can use theta. Okay, so now you can plug all the numbers. Okay, I can write. So it's a 1.6 times 10 to the power of minus 19 coulombs. That's the charge. Charge of a proton in absolute value equals to the charge of an electron. Right, so then velocity, of course, 1 times 10 to the power of 7 meters per second, and magnetic field 0.5 Tesla, and sine of 45 degrees, right? Okay, you can calculate it through. I'm not going to do it, and the answer is 5.7 times 10 to the power of minus 13. And it's just a force. Of course, nature of this force is magnetic. It's a magnetic force, but it's still a force, so unit of newtons. So it's a quantity which describes interactions of the interaction of this particle with the magnetic field, or we can say with the object which created this magnetic field. But of course, we don't know which object created this magnetic field. So we can say that interaction of the particle with the magnetic field. Okay, and this is actually, yeah, I should have written it's part A. It's a part A. All right. We need to write it in a component form. Right. So basically, I want to write it in this way. Which way I wrote it? Okay, using parentheses. Okay, F equals. So X component, then Y component, and Z component. So what's the X component of this force? 0. Because the whole force is in the Y direction. So it means that X component is 0. So 0. Then Y component, of course, this. 5.7 times 10 to the power of minus 13 newtons. And then Z component also 0, because the whole force is in the Y direction. Okay. This is also part of your homework, but in the homework you have 2 parts, A and B. So you need to repeat part A. Of course, numbers will be randomized most likely. In part B, yeah, it's somewhat similar, but I think the particle will be negatively charged. But you can easily adjust. If you're familiar with calculation of the cross product using a determinant, okay, you can use that, right? So at some point I stopped using that method in these problems. I just usually divide into 2 steps: finding a direction and finding the magnitude.